Number 11. Number 11 covers section 12.2 on the independence test. The contingency table shown to the right gives a cross-classification of a random sample of values for two variables x and y of a population. Find the expected frequencies. Note you will first need to compute the row totals, column totals, and grand totals. I'm going to show you two ways to do this, guys, by hand and by using the calculator. So if we do what it says in part A, if you do the row totals 10 plus 30, 40, 40 plus 20, 60, 10 plus 40, 50, 50, and the grand total is 100. Here's how you compute the expected values for each of the observed values. For 10, look what you do. It's very easy. What is the total in the row that contains 10 is 40. What's the total in the column that contains 10 is 50. So you multiply 40 times 50 and divide by the grand total. For 30, what's the row total here? 40. What's the column total? 50. 50 times 40 divided by 100. And you do the same thing for 40 and 20. You get here 20, you get a 20. That's where you see the answers. 60 times 50, it's 100. 3,000 divided by 100 is 30, and then you get 30. So this is how you answer the question. Now, how do you find the test statistic? In order to find the test statistic, there's quite a bit of work involved in there. You can do that by hand, or you can do it using the calculator. So I'm going to show you, first of all, the by hand part. First of all, you put the O's, the observed values, and then you put the expected values that you got. 30, 30. Then you subtract O minus E, you get negative 10, 10, 10, and negative 10. Then you square each one. This is O minus E squared. Then you divide O minus E squared by E. So this is 100, and what is E? These are the E's right there, divided by 20. And this is 100 divided by 20. And this is 100 divided by 30. And this is 100 divided by 30. And your test statistic is the sum of all those values, which is 100 divided by 20 plus 100 divided by 20 plus 100 divided by 30 plus 100 divided by 30. And you get, if you add them up, guys, you will get 16.67 as in part B. This is one way to do it. I will show you the calculator way. Decide at the 5% level of significance whether the data provides sufficient evidence to conclude that the two variables are associated, related. Here is always the null hypothesis, the variables are independent. And the alternative hypothesis, always the variables are dependent. Not associated means independent. And associated are related or dependent. He wants to check if this is the case right here. So this is the claim right here. Now the critical value. Actually, I put the same question twice. One with the p-value and one with the critical value. However, on the test, you could use the p-value if you want, if you see a question like that. But let me show you how to find the critical value here. Here's how you find it. You need the degrees of freedom, and you need the degrees of freedom, and then you need alpha, and you need to use table 8. It's table 8. Okay, here's how you do it. This is table 8. I'm going to show you. It's right there. So you look for alpha, which is 0.05. It's right here, guys, as you can see. Right here. And then you look degrees of freedom. Now, what is the degrees of freedom here? It's number of rows minus 1 times number of columns minus 1. How many rows do I have here? I have 2 rows and then minus 1. And how many columns? 2 columns minus 1. So the degrees of freedom actually is 1 here. So look, this is 1 here. And then I have to look for 5%. And the 5%, I have a 3.841. You can see, guys, that 3.841 as the critical value. How do you make a decision using a critical value? This is how it works. Okay. It's always a right tail test. The goodness of fit test and dependence tests are a right tail test. So this is the critical value, which is 3.841. And then you bring your test statistic, which is 16.67. It turns out to be right here. So it's in the rejection region. You end up rejecting the null hypothesis. So if your test statistic is always bigger than the critical value, you reject the null hypothesis. So we reject the null hypothesis and we conclude that the data provides sufficient evidence that the variables are associated. Now, how to do this using the calculator, I think we'll come to it in another exercise. It's exact same exercise, but using p-value approach. So I will show you how to do that in a few minutes. Next question. It's about section 12.1. A manufacturer of colored candy states that 13% of the candy in the bag should be brown, 14% yellow, 13% red, 24% blue, 20% orange, 16% green. A student randomly selected a bag of colored candies. He counted the number of candies of each color and obtained the results shown in the table. So they give you the results in the table. Test whether the bag of colored candies follow the distribution stated above. For the goodness of fit test, guys, your claim should be the distribution. For HO should always be the distribution of color is the same or is as claimed. Or an HA, the distribution has changed or is not as claimed. And what is the question here? Test whether the bag of colored candy follow the distribution stated above. So my claim is in HO here. Okay. In order to run this test, you need, these are the observed values, you need the expected values. And I'm going to show you how he did the expected values here. This, you have to do it by hand. You have no choice. Even if you use technology, you still have to do that by hand. Okay, how many did he say the brown? 13%. So you need 13% of the total. And what was the total in this question? We need to count them up. So we need to add all of those. So 63 plus 63, let's add them up. So that's the first task. If it doesn't give you the total, you have to add them up. 63 plus 63 plus 56 plus 63 plus 80 plus 65. I got 390. So this is 13% of 390. And let's compute that and see if we get 50.70. 0.13 times 390. Here you go, 50.7. For the next one, guys, the yellow says 14%. So you do 0.4 times 390. And for the red, he says, okay, 14%. For the red is 13%. It's the same thing we did already. And then for the blue, he says 24%. So you do 0.24 times 390. For the orange, it's 20% times 390. And then for the green, finally, it's 16%, 0.16 times 390. After you get your observed expected values, you can do the find the test statistic by hand, or you can use your calculator. To do this by hand, this is how you should do it. So you list the O's, you list the E's, and then you have to do the O minus E for each. Then you have to do the O minus E squared for each. So the O minus E, for example, would be 63 minus 50.7. I'll just do one here, which is what? 12.3. Then you have to do O minus E squared. So you have to do 12.3 squared, which is 151.3. Then finally you have to do O minus E squared divided by E, which is 151.3 divided by E, which is what? 50.70. And you have to do that for each category. You do it for 1, 2, 3, 4, 6 categories, and you add the last column. However, I'm going to show you a shortcut in how to find the test statistic using the calculator. So watch. You go to Stat, Edit, you enter the observed values in L1. So watch very carefully here. So these 63, it's very easy. 63, 56, 63, 80, 65. And since he only wants to test the statistic here, he's not asking you to show the work, so I could use the calculator, no problem. The expected values, guys, you have to do that by hand. So you have 50.7, you have 54.6, 50.7, 93.6, 78, and finally 62.4. Okay, now let's go to stat, tests, scroll up, and for section the dependence test is at 12.1. It's the goodness of fit test, it's D. Okay, you can see it's asking you to tell where the observed values are. They are in L1. The expected values are in L2. Degrees of freedom, that's very important. The degrees of freedom for the goodness of fit test is the number of categories minus 1. I have 6 colors, minus 1 is 5, so you must enter 5 here. Calculate. Okay, your test statistics, guys, is 14.994, and look, it matches with the answer right there. Your p-value is 0.0104. Well, he wants a 3 decimals, so 0.010. So that's how you use the calculator to do that. 0.010. And this is less than alpha because he gives me alpha to be 5%. So reject HO. So we reject HO. And if we reject HO, that means the distribution is not as stated by the manufacturer. It must have been different. So this is the conclusion right there. Okay, so that's number 12. Number 13. That should be very quick. Assuming a significance level of 1% and use the given information to complete part A and B. Original claim. Women have heights with mean equal to 152.2. Okay. Equal. That means the claim is in the null hypothesis, 152.2. So this is the claim. You know what the alternative would be? Not equal. Okay. The p-value is 0.1959. Well, the p-value is bigger than alpha. If the p-value is bigger than alpha, you fail to reject HO. So you select this one to begin with. Now, without using technical terms, state the final conclusion that addresses the original claim. Which of the following is the correct conclusion? Okay, we fail to reject HO. And the claim happened to be in HO. That means we cannot support the claim. We cannot reject the claim. I'm sorry. When the claim is in the null hypothesis, we don't use the language of support. If you fail to reject HO and the claim happened to be HO, you just say, I cannot reject the claim. There is not sufficient evidence to warrant rejection of the claim. You only use the word support if the claim is in H1. Okay. This is the same question that we did, I think, number 11 probably. And we did it with a critical value. Now we're going to do it with p-value approach. Okay. The contingency table shown to the right gives a cross classification of a random sample of 2 variables x and y population. Find the expected frequencies. Note, you will first need to compute the raw totals, column totals, and grand totals. And determine the value of the chi-square statistics. Decide at the 5% significance level whether the data provides sufficient evidence to conclude that the 2 variables are associated. So again, the 2 variables are independent. If you don't want to use the word associated, means independent. And associated means related or dependent. It's the same wording. So if you come across those words, they're exactly the same. So this is our statement. Let me show you how you could have done this exercise using the calculator. You don't need to do any work by hand whatsoever. So here's how you do it. So please pay attention. It requires that we do some algebra. This is a table. Is there a way in the calculator to key in a table? Yes, through matrices, and I'm going to show you how to do that. So you press second, matrix, you go to edit, A, and you select a 2 by 2. And then you put that, go there 10, the next entry is 50. It's not the exact same exercise. He swapped the value, so the the output is going to be slightly different, 30 and then 20. Okay? And now quit. We're done. Now go to stat, tests, scroll up, chi-square test. It's a chi-square test. When you do the independence test, it's chi-square test. Let me write it down here. And then the observed values are in A. The expected values, guys, you don't need to worry about them. They will be done for you automatically in B. And that's it. Hit calculate. Test statistic is 22.131. Here you go. 22.13. The p-value, you see the e minus 6, that means this is 0.000002, which is, if he says round to 3 decimal places, it is 0. So the p-value is less than alpha. We reject HO. And if we reject HO, the data provides sufficient evidence of association. So here, independent, that means that we can support the alternative hypothesis. That means the two variables are related. There is strong evidence at the 5% level of significance to support the claim or to conclude that the variables are associated, means related. Now the question is, if he wants you as a part of the question to find the expected values, how do you find them? After you run the test, guys, let me show you how to find the expected values without doing any work. Go to second and matrix and go to B. You see B is created for you now. Just press enter and press enter again. And here you go. These are the values. 21.82, 38.18, 18.18, and 31.82. These are the values. Okay? So that's number 14. Next question. 15. Test whether mu1 is less than mu2 at the 0.05 level of significance for the sample data shown in the accompanying table. Assume that the population are normally distributed. Okay, here is the table, guys. It's right here. So it's a two-sample t-test. Once you see an S, you know it's a two-sample t-test. So let me enter the values together. And we want to test that mu1 is less than mu2. So you guys agree with me that this is the null and the alternative hypothesis, and this is where the claim is. And let's make sure that we get the same answers as the answer key here. So you go to stat, tests, two-sample t-test. Okay. It's not data, it's summary. And you can see for population 1, I get n is 31, x bar is 103.4, and then 12.2. So I'll enter them. And n1 is 31. Now x2 bar, as you can see, I got 114.5. And for S, I got 13.2. And for N, I got 25. Okay? So this is what we have right there. And then we need to test that mu1 is less than mu2. By default, if he doesn't say anything, by default, pooled is no. Now, when do you put yes? If he says the population variances are assumed to be equal, we use yes. Otherwise, by default, is a no. So population variances are equal is a yes. Population variances are not equal is a no. Nothing said. We'll just, it's a no right there. Okay, so enter, calculate. Okay, I got p-value to be 0.001, and the test statistic, if he asks you to find the test statistic, it's negative 3.235. All right, and this is the p-value, which is less than alpha. We reject HO. And we reject HO, and since the claim happened to be in H1, we support the claim. There is sufficient evidence to conclude that mu1 is less than mu2. Next question. 16. All right, let's do 16. The mean weight of beauty pageant winners is 117 pounds. A study of 25 randomly selected beauty pageants resulted in a mean winner weight of 122. Original claim, it says is. Is means equal. So mu equals 117. That should be your null hypothesis. This is where the claim is. And H1, guys, will be what? Mean not equal 117. So this is how you identify the null and the alternative hypothesis. And that's it. That's all. That's the question. That's 16. 17. I believe that's the last one. According to food website, the mean consumption of popcorn annually by Americans is 54 quarts. The marketing division of the food website unleashes an aggressive campaign designed to get Americans to consume even more popcorn. Complete parts A through C. Determine the null and the alternative hypothesis that would be used to test the effectiveness of the marketing campaign. So we're talking about means here. We have to put means, okay? And that's always equal for the alternative, for the null hypothesis. For the alternative, they want to increase the consumption, so it's a greater than 54, and that's where the claim is. Although it says at the very beginning it is 54 quarts, but you gotta follow the question, guys. It says it is the marketing division that's trying to increase the consumption, so we'll just that's where the claim is. A sample of 852 Americans provide enough evidence to conclude that marketing campaign was effective. Provide a statement that should be put out by the marketing department. Okay, well, if they say that it is working, then you say there is sufficient evidence to conclude that the mean consumption of popcorn has risen. That makes sense to use this statement. Okay, C. Suppose, in fact, the mean annual consumption of popcorn after the marketing campaign is 54 quarts. So they're supposing that it is 54. Has a type 1 or type 2 error been made by the marketing department? If we tested the hypothesis at the alpha equals 0.01 level of significance, what is the probability of committing this error? Select the correct choice below and fill in the answers. So we're assuming that this is really true, but we ended up supporting the claim. That means we make a mistake. When this is true and you reject it, guys, that means you made a type 1 error. This is a type 1 error. So if you want to choose the correct answer, will be the marketing department committed a type 1 error because the marketing department rejected the null hypothesis when it was true. Okay, so this, I think that's the last question that concludes the review of the test. I hope that will be useful.